So let's go on to our next question, guys. The 13th question. It is based on algebra. Very beautiful question. If x plus 6 root 2 raised to 1 by 2 minus x minus 6 root 2 raised to 1 by 2 is basically 2 root 2, then x equals. Okay. Now there are two ways of approaching this problem. The first approach is we have to observe that we have taken square root of x plus 6 root 2. It's a surd. And square root of x minus 6 root 2 is also a surd. And we have got 2 root 2, right? Okay, so what we have to understand is by taking square roots of a surd, it is implicit that this surd is of perfect square, meaning this surd here is of the form a square plus b square plus 2ab, where a square plus b square is worth x and 2ab is worth 6 root 2. Okay, and that's our whole target now. We need to figure out the value of a square plus b square, which will be equal to x. And as a check, you can confirm this side we have a square plus b square minus 2ab. Yet again, a square plus b square will give you the value of x. So now for time being, we simply substitute x plus 6 root 2 as a square plus b square plus 2ab. So the first part becomes a square plus b square plus 2ab raised to half. And again, in place of x minus 6 root 2, we substitute a square plus b square minus 2ab. So it will become a square plus b square minus 2ab raised to half. And this should be equal to 2 root 2. Okay. The next step is this part is a plus b the whole square. The square root is nothing but a plus b only minus. This part is a minus b the whole square. The square root is a minus b only. And a plus b minus a minus b is 2 root 2. When we open the bracket, we get a plus b minus a. Minus of minus b is plus b. It will be equal to 2 root 2. A and minus a cancel. Further, we get b plus b, that is 2b. 2b is 2 root 2, or b is equal to root 2. Okay, so we are already halfway there. We have found b as root 2. And we also know that the 2ab term is nothing but 6 root 2. So if 2ab corresponds to 6 root 2, we can put b as root 2 here. I'll get 2 into a into root 2 is 6 root 2. Root 2 and root 2 gone. 2 1s are 2 3s are. I'll get the value of a as 3. And now we have got a as 3, b as root 2. Our target is to get x, which is a square plus b square. So the value of x, which is a square plus b square we have taken, is 3 square plus root 2 square, which is 9 plus 2 or 11. Okay, so our answer is 11. Alright, so now let's look at a slightly better way of doing this instead of substituting and resubstituting. We know that this should be a perfect square. And so is this term. These two terms are basically perfect squares whose square roots we are taking and subtracting to get 2 root 2, right? So let's represent this as a perfect square in the first place to make things easy. This is 6 root 2. Visualize this as your 2ab term. So this should be 2 into 3 into root 2, right? So if 2ab term is 2 into 3 into root 2, the latter part should be 3 square plus root 2 square, right? Because only then you have a perfect square, a square plus b square plus 2ab, right? And we're taking square root of this. Naturally, this is a plus b the whole square, right, guys? So 3 plus root 2 the whole square. The next step is you're taking the square root. Ultimately, you will get 3 plus root 2, isn't it? And similarly, in this second term, when you solve this, ultimately you will get this as 3 minus root 2. By the same logic, the last step is we'll be subtracting these two. So if you can see, this whole thing minus this whole thing is actually 3 plus root 2 minus 3 minus root 2, right? This is 3 plus root 2 minus 3. Minus of minus makes it plus. Minus 3 and plus 3 gone. The final answer is nothing but 2 root 2, and that matches, right? So what we had assumed is absolutely correct. We had assumed 2ab as 2 into 3 into root 2. So a is 3 and b is root 2. The value of x is 3 square plus root 2 square directly. It will be nothing but 9 plus 2, that is 11. And that is the answer to our question. So it is more or less the same thing that we had done previously. We are not substituting or resubstituting. We can directly split the term as a square plus b square plus 2ab and a square plus b square minus 2ab. In this case, directly we'll get x as a square plus b square, which is 11.